Good morning, scholars. Welcome back to the channel. This morning we're going to be solving algebraic equations at the grade 4 level. So in the video before this one we looked at just writing equations given scenarios, given situations. We change those into algebraic equations. So now we're actually solving these equations using addition and subtraction. Now the idea is we're given an equation and we want to find what's the numerical value of the variable. What is n? What is x? What is p? Which number, when I add 9 to it, I get 20? Which number, when I take 3 from it, I get 31? We want to find out what's the value of the number that we're representing with a letter in the equation. Now, what we do in order to solve these equations, we are going to do the opposite operation of whatever the operation is that we have working with the variable here. We're going to do the opposite operation. Why? Because we want the variable by itself. Remember, we want to find out what is n, what is x. So we want to isolate to get that letter by itself, preferably to the left-hand side of the equation. If we can't do that, then okay, we'll work with it on the right, but preferably on the left. And in order to do that, if we do the opposite operation of what we're working with, the other term, the constant term, the number term, we're going to cancel it out from the left, and kind of it's like we're moving it to the right? That's a way of looking at it. So we're adding 9, so if we take 9 from both sides, now you have to do it to both sides in order for it to work, because we don't want to change the equation, right? So think of it like a scale. So if you have something on a scale, you're balancing two things on the scale. So it's like this, right? If you don't want to change it, then you have to do the same thing to both sides. If you're adding something to this side, you have to add the same thing to that side, and it remains the same. Or if you're taking something from this side, you have to take the same thing from the other side for it to remain the same. You get what I'm saying? So we just want to rewrite the equation in order to get the letter on one side. We don't want to change the equation. We don't want to change the value of the equation. So whatever we do to get the 9 from here, which is the opposite operation of adding 9, we're going to take 9 to get 0 here, so we're left with only the n. We have to take 9 from this side as well to balance it out, so we don't change, because we don't want to change the equation, right? We want the original value to remain intact. So if we just took out the 9 and left the 20 without taking 9 from the 20, we have changed the equation and our answer would be wrong. We would have skewed it. So that's the principle we're going to operate on. We're saying we want to get the letter by itself. Whatever else is being done beside the letter, we're going to do the opposite operation of that to get rid of that number, to cancel it out to 0. So in other words, we're using the additive inverse. That's really what we're doing. Let me write that term. Hopefully you can see what I'm writing here. The additive inverse. The inverse means opposite. So adding 9, subtracting 9, those cancel themselves out. The additive inverse of 9 is to take away 9, and it would give you 0. Additive inverse of taking away 9 is adding 9. So we want n by itself. We're going to take away 9 from both sides. When we take away 9 from 9, we get 0, so we're left with n. And when we take away 9 from 20, we get 11. And there we have solved our equation. See, we found out that n is 11. Now, whenever you solve an algebraic equation, it's a good idea to go back and plug this answer into the original equation and see if it makes sense. So let's do that. We're saying n is 11. Is it true? If I take 11 and plug it in here, 11 plus 9, do I get 20? Yes, I do. 11 plus 9 gives 20, so we know that we're correct. So whenever you solve an algebraic equation and you get a numerical value for your variable, so if you say x is equal to that, n is equal to that, p is equal to that, take that number and substitute it, plug it back in to the original equation where that letter was, and see if you end up with the same answer, and you'll know whether you are right or wrong. Alright, so we have x plus 8 is 15. We want x to be the only thing on this side because we want to know what is x equal to. So since we're adding 8, we're going to do the inverse of that, the opposite of that. The opposite of adding 8 is subtracting 8. And we have to do the same thing on this side to balance it off so that we're not really changing anything. Whatever we do to this one, we do to the other. It's the same. So now, the 8 minus 8 gives 0, and we're left with x here. And the 15 minus 8 is 7, and we have solved our equation. X is 7. Let's plug it back in and check. If we're saying that x is 7, 7 plus 8 is 15, that is correct. If we add 7 and 8, we do get 15. So the value of x is actually 7. So let's see here. P, a number plus 16 gives 32. The additive inverse of 16 is minus 16. We need to do the same thing over here to balance it off. So 16 take away 16, that's going to leave 0. So we only have P now on the left. And 32 take away 16 is 16. So the answer is 16. If we plug this back here and add 16 plus 16, do we get 32? 16 plus 16, 6 and 6, 12. Yes, we do. So when we check our answer, we see that P is actually 16. 16 plus 16 gives 32. Which number, when you add 5 to it, you get 11? We're going to do the additive inverse of 5, which is to subtract 5. And we're doing it on both sides to balance things off. So we're left with x alone here, and 11 minus 5 is 6. And if we plug back 6 here, 6 plus 5 does give 11. Which number plus 14 gives 30? So we're going to take away 14 from both sides. We're only going to have W on that side now. And 30 take away 14, that gives 60. And if we plug back 16 here, 16 plus 14, let's check. 16 plus 14, we do get 30. So we know that we are right. Alright, so now they kind of switch things up on us and they put the number that we need is closer to the equal sign and the constant term is the first term. It doesn't matter because guess what? Addition is commutative. It doesn't matter which one you put first. It's commutative. You'll get the same result. So again, we're just going to do the additive inverse. We're going to take 25 from both sides because we want n alone on the left. Alright, so when we take 25 from 25, that's 0. So we're left with n. And 52 take away 25 would give 27. So n is 27, and we can always plug this back here. 25 plus 27 would give us 52. always double check. Once you have enough time at the end of your work, and you usually do have enough time, plug in back your answer and double check. Alright, so 10 plus which number gives 19? We're going to take 10. Since we're adding 10, we're going to do the inverse and take 10 from both sides. That gives 0. So n is equal to 19 minus 10, which is 9. 3 plus which number gives 17? We're adding 3, we're going to subtract 3 from both sides. That gives 0. 3 take away 3, that's 0, that's gone, nothing there. X is equal to 17 minus 3 is 14. 12 plus which number gives 16? We're going to subtract 12 from both sides. The additive inverse. That's going to give 0, so we're left only with P. And 16 take away 12, that gives 4. So 12 plus 4 gives 16, and that is correct. 12 plus 4 does give 16. 20 plus which number gives 25? Let us subtract 20 from both sides. To balance it off, we have to do it from both sides. If we don't do it on both sides, we're changing up the whole equation. Our answer will be incorrect. So that gives 0. We're left with x. And 25 minus 20 is 5. And if we plug in 5 where x is, we'll see that 20 plus 5 does give 25 in the original equation. Alright, so let's look at some now that have subtraction. Which number, when you take 4 from it, you get 42? Again, we want the variable by itself, preferably to the left. Can be on the right if we can't find any other way, but we prefer the variable to be on the left. So we're going to do the inverse of subtraction, which is to add. We're going to add 4 to both sides. Negative 4 plus 4, that's 0. Okay? And so we're left with x on this side, and 42 plus 4 gives 46. If we plug in our answer to check, we will see that plugging in 46 here, 46 take away 4 does give 42. That's how we know that we are correct. Which number, when you take 6 from it, you get 19? We're going to add 6 to both sides. When we work with the inverse, that's how we'll end up with a 0 because we just want the A. But we have to remember to do the same thing on the right in order that we have not really changed the equation. Remember our balance, once you do the same thing to both sides, you have not really changed the equation. So negative 6 plus 6, that will give 0, and we're left with A on the left. 19 plus 6 is 25. And if we plug in 25 here, we do see that 25 take away 6 gives 19. Alright, so which number, when we take 3 from it, we get 31? Which number, when you take away 3, you get 31? Let's add 3 to both sides. This will give 0. Negative 3 plus 3, that's 0. And W equals 31 plus 3 is 34. Which number, when you take 5 from it, you get 9? So let's add 5 to both sides. So that gives 0, and we're left with x equals 14. Which number, when you take 1 from it, you get 1? Which number, when you take out 1, you're left with 1? Let's add 1 to both sides. So negative 1 plus 1, that's 0. The additive inverses give 0 when you combine them. And B is equal to 2. Alright, so we have a couple left to go. This time, They put the variable on the right. Okay, we prefer it on the left, but if we have to work with it on the right, that's fine as well. So we're going to add 6 to both sides to cancel out the negative 6. 12 plus 6, that's 18, so x equals 18. If you want, you can rewrite this with the variable on the left, just because it is preferred that way, or you can leave it as that. They're the same thing, right? So we're going to add 14 to both sides here. So we get 39 is equal to P, or P equals 39. So we're saying 39 take away 14 will give 25. When we plug back the answer into the equation, it should be true still. That's how we check. 18 is equal to which number take away 9? We're going to add 9 to both sides. 18 plus 9, that's 27. Y is equal to 27. 27 is equal to y, same thing. Now, the variable is the one with the subtraction sign in front, right? If we get rid of the whole number, we're still going to be left with a subtraction sign. We don't want a subtraction sign in front of the variable. So the best thing to do in this case, when you have a minus sign in front of the variable, the best thing to do is to actually add the variable to both sides, which will give you a positive variable on the right. So what we'll do is we'll add x to both sides. So we'll get 16 is equal to 4 plus x. And then we take 4 from both sides. So 12 is equal to x. Or x is equal to 12. You see that? We don't want a negative x. We don't want a negative x. We want a positive variable. We don't want a minus sign. If we just took out the 16, we'd be left with a minus x. So the best way forward, when you have a minus sign in front of the variable, take the variable from both sides. Sorry, add the variable to both sides. So you end up with a positive variable on the right, and then you proceed like you normally would. So we're going to add y to both sides. We're going to end up with 10 is equal to 9 plus y. And now we're going to take 9 from both sides. So 1 is equal to y, or y is equal to 1. So 10 minus y gives 9. See, we're correct. Finally, 7 minus p gives 0. So let's add p to both sides. So we'll end up with 7 is equal to p, and that solves our problem already. P is 7. 7 is equal to p, p is equal to 7. So that's it for addition and subtraction. The next video we're going to look at solving algebraic equations using division and multiplication at the grade 4 level. So remember, once it's subtraction or addition, we use the additive inverse principle. If we have a positive number and we subtract the same number from it itself, we get 0. Negative number, add the same number to itself, you get 0. And we do that in order to cancel it out from the left or the right, so you're left with only the variable, because we just want the variable on one side. We want x equal whatever, or p equal whatever, just p or x, just the letter. Preferably we want it on the left. If we end up with it on the right, it's not an issue. We know how to, we can just rewrite it in the elegant way. In mathematics, there are certain ways we call the elegant way, which is just the preferred way to write it. It's not that the other way is wrong. It's not that it's wrong to say 27 equal y. It's just preferred for you to say y is equal to 27. So you can get your answer. You end up with the variable on the right. Just turn it around. Rewrite it with the variable on the left. Alright, so if you have benefited from this video, just drop a line to say thank you, miss. for your efforts, and I would appreciate that comment. I would appreciate it if you share the video to as many students as you can, so we can remove this fear of math. Remember, that's our mission. That's our ultimate mission, is to remove the fear of math that exists in children and adults alike. We want everybody to embrace math, to love math. So share this video with as many persons as you can. If you have not yet subscribed, please subscribe. And if you check our catalog and you don't see a video for a particular topic that you are yearning to master, drop a comment and let me know which topic that is, and I'll do a video for you. Thank you for joining me. I'll see you in the next video.